Morning. Okay, today for attendance, let's look at this question. It's been a while. It's one of those questions in chapter 3. We should be able to find the derivative even if the function is given by equation. So you have a formula for y equal to f of x, and that's considered an explicit function. But if we don't have the formula for y, and y is being presented in the equation. This equation represents relation between x and y. This kind of function is called implicit function. To find the derivative of this kind of function, you have to find the derivative of the left side, which you put on the derivative of the right side. This process is called implicit differentiation. Although we know that controls the integration process, we would find the derivative of the left side and the right side. The derivative of the left side equal to the derivative of the right side. So that is the symbol for the process of differentiation. So this symbol says ddx of 1, that is the rate of change of 1 with respect to x. So numerator is how much changes in 1, denominator is how much change in x. But because x is 1 is a number, when 1 is changing, since 1 is not related or not connected using x value. When the x value is changing, the 1 really has no change. Therefore, the right side equal to 0 because rate of change is 0. Finding derivative basically is finding the rate of change. And that's why when we were working on the related rate, we're finding the rate of the left side and set equal to the rate of the right side. All right, and now we have to find the derivative of the left side. And know that we think the variable is x. You can actually find the dy if you want to. In Calc 3, we sometimes have to watch out for the variable that you're differentiating for. Right now, we're normally, as a tradition, x is an independent variable, so we normally do ddx instead of ddy or ddt. So anyway, if you use a completely different variable, say if I write like a variable that's not in here, then the rate of change will be 0 since the expression has nothing to do with variable u. But here we have a variable x, so if you find the derivative of x cubed, the derivative will be 3x squared. All right, now if you find the derivative of x times y with respect to x, this is multiplication of two things. Negative x is one, y is another. This is multiplication. We have to do product rule. If you differentiate the negative x, you get negative 1 multiplied by y. Or if you keep the negative x and find the derivative of y, that is dy dx, that is y prime. So that is the product rule applied to negative xy. And lastly, we have to differentiate the 3y squared. Now, according to power rule, 3y squared. But in this context, the y is not a variable in itself. Y is actually a function of x. So if you are looking at it, this is actually f of x cubed. So if you try to find the derivative of f of x cubed, you have to do 3y squared times the derivative of f of x. So what to multiply by y prime? Because y is not a variable, y is a function. So in the implicit differentiation process, the two variables x and y. X is the independent variable, y is a function of the variable x. That's different from related rate. When we were working on related rate question in 4.1, all the variables are functions. So that was the process. See you already answered. Find your Adrian, I'm sending you your Thank you. So for this question, being able to find the correct derivative from the left and from the right, it is very important. It's the main procedure. Focus. Let's see. Am I too far? Okay, thank you. Right, so we finished differentiating the left side and right side. Please get your answer. That's right, thank you. So you realize that we are trying to find the dy dx, which essentially is y prime dy dx. That is normally very often the textbook way to write y prime. Y prime is just a way to shorthand the derivative, and y prime is definitely more faster to write, but if you want to avoid confusion, writing dy dx is more formal. So anyway, we're trying to find the y prime, which is equal to dy dx, and out of the entire process, we see the y prime only appear twice, this one and this one. So in order to find the formula for y prime, we have to move it all the way to the term that has y prime, leave it on the left, and the one that has no y prime. So it's going to be negative x prime plus 3y squared. They'll stay on the left, and then the other two terms has no y prime, they move to the right, which is negative y become positive y. Positive 3x squared, negative 3x squared. Because if you want to move it out, if you want to remove a 3x squared, so you would minus 3x squared. Whenever the term change size, it will switch to a different side. That is if the combination is through summation and subtraction. If there's multiplication, we certainly should be division, but these two are additive to the left side equation. That's why we did a simple summation or subtraction. Once we get to there, we have the y prime factor. Without the y prime, this is the factors. Y prime, 3x squared. You're going to have the y prime solved in the division. to y minus 3x squared divided by the factor, which is negative x plus 3y squared, or 3y squared negative x. The order doesn't really matter, but we try to follow the choices. So this is the entire process for determining the derivative. This is every let's answer where we put it. That's the attendance right now. Do you have any questions? Today is the last day of class. So after today, we will not have any regular meetings. I will still be in the Math and Science Learning Center the same time as normally after our class. I'll be there. So I will still be there. If you want to meet me every morning, you can find me there. Not all the time. Sometimes I might have exam. Let's see. Find out what's my exams. So our exam is number 6, which kind of would probably be the.
I thought it was the 7th.
Yeah.
Right. December 7th in the morning. Sorry. December 6th, I have another exam. So basically, I won't be able to be in the math lab on December 6th because I have to capture exam. But I will be there tomorrow morning. I should also be there in the afternoon. So let me know what time you wanna, if you got questions as you try to prepare. But in the meantime, this is the last day of class. Our homework is due, they're all due tonight. So if you have any remaining homework, try to complete them tonight, before tonight. So then I can load it up on Georgia View. The homework test is already done. If you have any makeup tests that you did and you don't see the new grade, let me know. They're either lower than the original one, or the testing center hasn't sent it to me yet. But all the graded when they're already on Georgia View. If you notice any problem with the grading, let me know. Class participation, the attendance also are posted on Georgia View up to week 14. But if you see any mistakes in there, you will let me know. I counted 10 points per day, so the whole week should be 40 points for all attendance, daily attendance. And then there's one last event that will be the final exam. That's really all the grades related. Any questions? If you're trying to prepare for the final exam, I did post a practice question on Georgia View. All right, anyone else want to submit your answer to the question on board? I put it, this is a calculation of the question. This is a question for implicit differentiation. It's your chapter 3. The process is try to find the derivative of the left side and the right side. And then we're trying to, after finishing the differentiation, identify where the derivative is and solve for it. Solve for it quite fine. Let's see. Differentiation. That's the one. Any more question? Okay. Please finish the post-test on quizzes under post-tool quizzes. There's a post-test for class assessments. And also, if you haven't finished the course evaluation, please do that. Today is the last day if you intend to submit a course evaluation. It should be, it is important. Which one is the question? It says a rectangle is inscribed with its base on the x-axis, its upper corner the parabola. So it will look like this. We start with this rectangle. The base is on the x-axis. The upper corner is base 2. They were on this parabola, so the parabola is like this. Right, this parabola has a negative x squared, so it has to be in this shape. But I'm trying to fit that so the corner will be on the parabola. And the actual relation between the parabola with axis is like this. And this point is where the x equals 0. In this equation, if x equals 0, you will have a tangent. So if you got a y-axis here, straight line. And then right here, the intersection will be 10. That's how the relation between the rectangle and the parabola. The formula for the parabola is y equal to 10 minus x squared. Whenever we were given the equation for any curve, that is a equation relation between x and y. So if you have a corner point right here, that is x, y. Now this corner point is on the parabola. So this x and y will satisfy this equation. So that equation is a relation between the corner value x and y, and that indicated that this is x. This is also x, negative x. And this will be the y value. This is also the y value, and this is also the x, negative x. So that kind of labels the distance around the rectangle. Then we can look at the question, what are the dimensions of such a rectangle of the greatest possible area? So one of the comparative words is greatest. That kind of is the same meaning as maximum, the highest possible area. So this optimization, we're trying to find the biggest rectangle that has a corner on there. But you see, there's really not a space, not a lot. So you can have a rectangle this way because the upper corner is going to be on the curve, or you can have a really tall rectangle. But whichever way, it looks like the one I'm drawing seems to have a bigger area than this. So the dimension really matters. So since we're trying to find the biggest area, then whatever you are trying to find the biggest value for, that has to be something you have a way to calculate it. So area is something we have to figure out a formula. And then with that formula, we find its maximum value. And it's the common steps when you're trying to look at optimization. Whatever you are trying to optimize, you gotta have a way to measure that. If you can't even measure it or calculate it, there's no way we can find the maximum value for it. So area for the rectangle, so the dimension of rectangle, area for rectangle, supposed to be length times base. Now, if you look at there's the green rectangle, the length is twice the x. X is positive, negative, x negative, but the total distance at the length is in that direction. Horizontal distance is twice the x, so L equals 2x. That's the length. And then the waist is really the height of the rectangle, which essentially is a single y value. So we're really trying to find the biggest value of 2x times y. And we have that issue that this thing that we're calculating have two different variables. But luckily, we have a relation between the variable x and y. X and y have y equal to 10 minus x, so the y value can be replaced by 10 minus x squared. So this area calculation is equal to 2x times 10 minus x squared. So that is going to be that's going to be the formula for the area. So we know this is the what we need to find the maximum value for. So fx is we distribute the 2x times 10 is 20x. We distribute the 2x with the x squared, that is negative 2x. X times x squared is 18. So that's the function we're trying to find maximum value for. And then we also have to identify the proper domain. If you think about the x value, or its smallest x value, it is when x equals to 0. At the upper corner value. So x is between 0 and this boundary. So x gotta be within this point and this point. So anywhere in here. If x went bigger than this, the point would be from here, and then that's not a upper corner anymore. Therefore, x gotta be between these two. You can have a rectangle this way or this way, but you can't have it this way because we're considering upper corner for the x value. So we have a interval that is x is actually between 0 and one other number. If you wonder what the other number is, you go set the 10 minus x squared to 0. Because the other number, it is on the x-axis. Any point that's on the x-axis will have a y value. So let 10 minus x squared equals 0. We'll have x squared equals 10. Since we're looking for a positive x, x has to equal to 10. So we have a proper boundary for the x that's between 0 and 10. Okay, then we would apply the max and min on the closing interval. We can actually find the derivative, let the derivative equal to 0, find a critical point right between these two numbers, and then that point should be the greatest dimension, which should be twice the x. That is the length of the rectangle. When we talk about dimension of the rectangle, we're talking about the length and width. So 2x is the length, the y is the width. So once we finish letting the derivative go, just into the answer your question. You can try to compare. I'm kind of shorten the explanation because the actual solution should be longer. Once you find a function, the rest is finding the derivative, setting the derivative. Right, so we have that function that goes 20x minus 2x cubed. So I'm only explaining what do we get from there. And then you find the derivative equal, find the derivative right equal to 0. And since the second derivative is -6, it's concave down, so there's a maximum. So we make the derivative 0, x equal to 10 over 3. That's the x value. Yes. Oh, that was a mistake. It's a good point. Yeah, I was wrong with that answer. Well, right. Yes, you're right. When we making find the derivative, it should be 10 minus 6x squared. So we let this equal to 0. Then we have x squared equal to 10 over 6. Yeah, it would be 20. So it's a 20 minus 6x squared, x squared equal to 20 over 6 or 10 over 3. Then x actually equal to square root of it. Square root of 10 over 3. That's the right x value. Yeah, thank you for pointing that out. That is definitely an error in the calculation. So I did make a mistake when I tried to find the derivative. It should be 6x squared. It's not 6x. And then causes the x. There's a missing square root sign there. But since the second derivative is -6, it is guaranteed whatever critical point you find out, at the critical point we should have a maximum value. Any questions? Yeah, that's a mistake. I'll submit a correction to this. Any other the solutions? But I should double check that word. Any other questions? -3, yes, that's right. Yes. So basically, the power was applied correctly here. So according to power rule, the power is -4. So the power plus 1 will be -4 plus 1, which should be -3. So here the answer should be 10 times x to the power -3 over -3 plus c. So if we combine, it will be -10 over 3. 10 to the -3 power c. You can also put the negative power to the denominator, so it's -10 plus x to the power -3 plus c. You can write -10 over 3 times x to the power 3, which is equivalent. I definitely wasn't applying the right power rule. All right, so when the power is negative, it's the negative power plus 1, which it looks like a smaller power. but the power is in the denominator, so it's actually isn't 1 power higher than the negative 4 power. There was no students. Any other question about the solution? This one, this is the one I wrote before. Didn't realize it was hasty. Didn't realize the mistake. Get the questions. I mean, if you try it yourself, you probably realize. So what's wrong with it? Any other questions? I hope there's no other mistakes. Did you try the rest of the question? Okay. Basically, it's all 5 chapter. I try to have a selected question from every chapter. So started with limit calculation, continuity, move on to calculation of derivative, and then application of derivative. The last part, which is starting from this question with integration question. If there's anyone that's not quite as familiar, that is the number 5. So intermediate theorem, intermediate value theorem. We have quite a few theorems in this entire class. We have mean value theorem, which was mentioned quite a couple of times. And then the other one is intermediate value theorem, which is from continuity. If the function is continuous, any value in the middle is guaranteed to be a function of like f is equal to k. And then we have derivative. For derivative, we have mean value theorem. And we have integration. We also have mean value theorem for integration. And then we have the connection between derivative and integration. That's the fundamental theorem of calculus. And I think I didn't really put it of that. I put some integration question here. I didn't put the fundamental theorem of calculus here. You can see whenever you are integrating a definite integral, you are applying the fundamental theorem of calculus part 2. Right? Fundamental theorem of calculus part 1 is when the function is being defined with integration, then the derivative of that function will be the integrand of the integration to another part of it. So basically, fundamental theorem of calculus part 1 is how do you go from integration, use the integration to find the derivative. And then the part 2 is how do you find using the derivative to find the integration value, the definition of the calculation of the definite integral using the part 2. Any other questions? So if you try to figure out a related question to practice, then starting from the new one, this is 5.5, which is a substitution method. Most of these are a substitution method involve exponential function, a substitution method involve trig function. And this is the 5.4, which is a definite integral. We find the definite integral value using the antiderivative formula. And then this number 20 is one of the questions in 5.1. So basically, one of the examples from 5.1, 5.4, and then 5.5. I skipped 5.2. That was the area, using area to find the definite integral. I also skipped 5.3. Which was the Riemann sum, because it's more time consuming to do a numerical calculation to see that part. And then if we move back, Newton's method, it was 4.5. And that is one of the popular numerical methods to find the solution to equation. If you wonder, there's one more numerical method to find the solution to equation. That is an intermediate value theorem, which is by trial and error. You plug in number for the x value, and if making the left side equal to the right side, that is a solution. But if this making the right side does not equal to the left side, you can find out whether making it positive or negative, and you can make adjustments to it. That's really the intermediate value theorem. Anything in between two that value provided entry to find more accurate solution. But Newton's method is more systematic. You can start with a value and start doing calculation, and you do the same calculation over and over. Your final answer will get better, more and more accurate. You work on more run of Newton's method. So very popular way to calculate solution for equation or calculating numerical. So Newton's method, you do need to know the derivative, but you don't have to graph it, and you also don't have to know the algebraic relation between the equation and the x value. That's easier to handle and to identify underlying relation around the equation. The solution always is. It's difficult. We have to do it case by case, but this is making it more systematic to calculate the x values of the equation. Number 18 is one of the maximum question. Chapter 4. Number 17 was related to the rate question. There's no guarantee which question in that section will be on the exam, but there's a guarantee that one question from that section will be on the exam. The 16 was the graphing, which belongs to 3.5 graph function. So this is now in chapter 3. And then this one was talking about contivity, and we were supposed to calculate second derivative. To figure out contivity of a function, we have to calculate second derivative, find inflection point, setting up the number line, and figure out the contivity on each part of the number, on each interval. And number 14 is about increasing, decreasing. In order to find out increasing, decreasing, we should find the first derivative. First derivative allows you to understand increasing, decreasing behavior. So I set the derivative equal to 0, and then those two numbers allow us to mark on the number line, and then on the number line being divided out into 3 intervals. On each interval, we're going to know if the derivative is positive or negative, which then allows us to figure out increasing, decreasing. And was 14, it's about increasing, decreasing behavior. Number 13 is mean value theorem. So we find the mean value of the slope, that was equal to a minus equal to b divided by a minus b. And then we let the derivative equal to the slope. That's how we find out the special number. So mean value theorem basically is saying it's guaranteed there's a special point in the interval. At that point, the derivative equal to the mean value of the slope. So that is the main idea of mean value theorem. Number 12 is a plain maximum and minimum value calculation of the closest. So that felt like very similar to the optimization process. The optimization process have a background, have a word problem setting, and you have to figure out what kind of thing you need to calculate in order to answer the question. So one of the main thing is not knowing which function to work with, which function to differentiate. But we all read a maximum on a function on the closed interval. And function is given, the interval is given, and we very much follow the procedure. You identify the endpoint, also identify which critical point is in that interval. So in this case, we have -7 to 2. So between -7 to 2, the critical point is x equal to 1. The other critical point, x equal to -9, is not in the interval, so we don't have to calculate it. That we set up a comparison for each x value of possible maximum. We find out the y value. That's one of the questions in 3.1. 3.4. Before that, don't quite remember in chapter 3 which section that one. Before that, the rest of the question are all basic concepts. So this is a derivative of inverse trig, and number 10 was derivative of log differentiation. You can use log differentiation, or you can use change of base. If you're able to change the base to e, and then the differentiation might be able to determine using the chain rule. Number 9 was quotient rule. Number 8 is product rule, and the derivative of the trig function combination. Number 5 is to find equation of the tangent line. This is the definition for derivative. We went all the way to the quotient. This is the difference quotient. Derivative, the limit of the difference quotient is a derivative definition. That's really the definition. We're trying to find the derivative of the function at 5. So you can actually find the derivative of this function and make x equal to 5. So we calculate -1.5. It's a limit value. But we're trying to review how do you find the derivative? How is the derivative defined using the limit definition? So originally in chapter 2, derivative is being defined as limit of that quotient. And now we figure out formula to do it. So once we learn the differentiation formula, we stopped using the limit, but still the underlying definition of derivative is still a limit of the slope. Now we have intermediate value theorem for continuity. Then we have continuity of piecewise defined function. You calculate the value and -1 from both equation and set it. Should be 4. And then we have a few questions. That's pretty much most of the section. The book has a selected question, but some of them are skipped because the computation time. But one of the considerations I need to take some questions. Any questions? So if you want to still see some questions, is the one we worked on for input simplification. This is pretty much how the final exam might be. There are 20 questions here. I might remove 1 or 2 questions to make a 20 question out of the whole set. But this is really the plan for the exam. It's very close to our actual final exam. The 7 is not too far from today. So we're gonna try to prepare for it. It's Thursday, which well, at least there's in the middle. I think it's the second day of the final exam. Yeah, December 7th is the second day, but so I'll try to stay close to the format. This format won't be identical. Some of the questions might be changed. Some of the questions might be removed. This is the overall plan. The cumulative assessment. Each type of the question. Ernest, were you able to answer this question? It should be easy. You did it a while ago. Oh, okay. Yeah, the answer should be C. It's implicit differentiation. What else? All right. So lastly, how many of you actually did all your homework questions? All right. I just want to remind you that they are all due today. I said it because it's the last day of classes. So at the beginning of the semester, I said them all due December 4th. On homework, I opened up all the homework. They're all due today at 11:59. So if you wanna get enough credit for the homework is 20% of their grade is the homework. So it's not a huge portion, but it's still pretty big. And if you want to get full credit for it, you can try. If you miss any tests, you should also let me know. And I'll try to schedule a time to meet with you this week. We can try to catch up tests. Remaining tests that you missed, you can make it up. So anyway, Thursday will be the last day. It will be our final exam. Try to mark it on your calendar, so you don't accidentally miss it. It's 8 o'clock. Yeah, it's 8 o'clock. It's very early, and then sometimes we'll overslept. In this room? In the same classroom, yes. You can bring one page of formula. You can bring your calculator, and then make sure you have enough pen and pencils. Yes, formula can be 4 pages. Okay. Let's see. I guess based on the title question, you might think of some formulas. Let's see. First question is on limit calculation. Anyone use formula for limits? I think you can try factoring. I don't really do formula with factoring. Another way to calculate this limit is L'Hopital. And if you forget what is L'Hopital, you might want to write down the formula for L'Hopital. For L'Hopital, the condition is the limit of the numerator equal to 0, limit denominator equal to 0. If it's 0 divided by 0, you can use L'Hopital. If it's infinity divided by infinity, you can do L'Hopital. But if it's number divided by number or any other situation, you can't do it. L'Hopital is not a one thing for all. It's one of the techniques that you run into this limit, the 0 divided by 0 or infinity divided by infinity, then L'Hopital will be useful. So consider the condition. Under which condition can you use L'Hopital? Under what other condition L'Hopital is not? It's not going to be correct. So such a part of the requirement. The second question is a similar situation. When theta approaches 0, the theta approach 0, numerator and denominator both have 0 limit, and therefore you can use L'Hopital, but you can also use other techniques. For example, I think we work on the chapter 1 at the beginning semester. That is, a limit calculation can be calculated 3 different ways. Number 1, you can use number, which is generally true for all limit calculation. For example, if theta approaches 0, try let theta equal to 0.001, and then you will be able to see roughly what is the ratio between numerator and denominator. Divide sine of 5 times 0.001 divided by 0.01. It will not be exactly equal to the limit value, but it's going to be a really good estimation. So numerical method is one approach to get to close to the true value. Another way to do the calculation is graphs. We are able to graph. Some calculator graphs and most calculators don't. But if you're able to find out the graph and then zoom into that 0, the 0 on the x-axis, you will see the limits or see the value. And then lastly is algebraic method, which may not be the case But algorithm method is what we aim for, and then the derivative calculus is Lobatal, factoring, or letting the data equal to zero. These are all algorithm. They don't always work. So you're doing algorithm method. You might have to try multiple methods until you're sure what is it. So all three methods can be combined. You can always combine numerical method with algebraic method, or combine the numerical method with graphing. So whenever more than one method are combined, the answers forget. Number 3 is the limit calculation. You make the s as a variable. The variable approach 8. And you can see numerous denominator both approach to a finite number. This limit calculation, we do not have to use all the code because we actually can calculate the limit using the substitutions. Substitute s for 8, and then basically calculate the root of the fraction. This is also the one that does not have the. So if I look at all these questions, I feel like the first 3 questions does not require any formula. You do have to know what to do with it. Less of a formula, more like the theory for how do you handle limit calculation. This one we're trying to find the value m, which is a coefficient that we try to determine. This is the purpose is to guarantee continuous. Most of the time, piecewise defined functions are not continuous. The one on the left is when for x is less than -1. The one on the right is when x is bigger than -1. We have the right piece and the left piece, and they're not connected in general. Only for special value of the coefficient m, they would be connected. When they are connected, that is when the x equal to -1 top one and the x equal to -1 bottom one, they should provide the same value. And that's really the idea for us to figure out, right? And because we're able to set up equations that m satisfy. Right, so this kind of question is for continuity. You can write some comment on the following page, like this kind of question. We should calculate the value of the function for the 2 different formulas, and they should be equal even on uncertainties. So you can write a remark if if you feel anxious about treating this kind of question. Number 5 is intermediate value theorem. I guess we'll see you will calculate the value of the function at interval 0, endpoint of the interval 0 and 1. So calculate after 0 and after 1. And one of them is lower, the other one is smaller. Any number between them is guaranteed to be a function value. So you can always find a value in between 0 and 1 that this value has improved functionality. This k is the intermediate value, and these 2 endpoints is the endpoint value at 0. You're going to calculate after 0, which is 8, goes in here, and calculate after 1, which is 16. Here. So any number between 8 and 16 is guaranteed to have a value c that after c equals that number. So the term intermediate value is talking about the k. K is the intermediate value between 2 function value. So there has to be intermediate value between the 2 values 0 and 1. So c is between 0 and 1, just like k is between the function value after 0 and 1. Again, I think as long as you understand the intermediate values here, we don't have to write a formula for this. But if you feel like you might forget how to do it, write a single remark. I'm trying to write it short because your formula might be very complicated. Any questions? Yes.
Can you do 5.3 problem 10? 10.
Number 10?
Yes.
This one is to drive the Riemann sum into an interval, into an integration. All right, so the 1 and 8 is a and b. So the first 2 number is already given out by the question itself. And then the delta x matches the dx. So this is this. This limit of the summation is the integration notation. Right? If you cover that up, this right in the middle, that's your f of x. So f of x is root 2x plus x squared. And that's the rest. So if you kind of match up the interval with your rule of thumb steps, so how I hope that answers your question. So anyway, A and B are the interval 1 and 8, 1 and 8, and then the px is a delta x. You kind of match it up, and the rest of them is matching the f of x. That's why the f of x is exactly this, kind of like what we have there. The d of x is delta x, and then the summation together with the limit value that is the integration notation. Everything in the middle is f of x. Let me kind of finish. Let's see what formula we need. Number 6, the formula will be the definition for derivative. If you remember that, you can rewrite it. That is derivative of the function of any function in equal limit of quotient. That is f of x plus h minus f of x divided by h. And h is approaching 0. Right, that was the original definition for a derivative. If you match that with what we have, it looks like we're calculating. We match with this question, we're calculating a line of 5, right? X equals 5. Change. So we're trying to find the root of this function. X value. The derivative is -1 over x squared, and then you plug in 5 for the x, so -1 over 25. Let's see, it's its limit value. But the process of simplification is really a practice of how do you calculate this limit. If you want to calculate this limit for a function, this function is something you have to do first. Number 6. Again, solution is in the book, I guess. This should be considered one of the main formula that we should learn in Calc 1. That's definition of the limit definition. Number 7 is to write the equation of the tangent line. Equation for the tangent line. We might have this already on your formula in chapter 1. That is a line. It's the equation of a line. So the equation of a line is y equal to the derivative value at the point of tangent c times x minus c plus f c. Right, that you can also say the y equal to m x minus x0 plus y0. That was the Poincare formula that we learned in college algebra, and this is a American way to say it. Basically, your point of tangency is c f of c. So c is the x value, f of c is y value. It's the same thing. And then the derivative, the slope, m equal to the derivative. You can write it both ways, but this is a method, the formula that we have in chapter 1. So you gotta find the numbers. They're actually numbered. For example, this one has x equal to 0, so c equal to 0. That was 0 in this question. And you also have to calculate f of c, which is f of 0. And what's f of 0? This is equal to 0. It's also equal to 0. That is negative 18. So this is a number. This is a number that was 0 and negative 18. And you also have to calculate the derivative, which replaces the f from the c. These are all numbers that's supposed to be replaced by appropriate values. Finish the calculation, but that's the formula. So this is the equation of the tangent line formula. It follows the Poincare formula that we learned in college algebra. If there's any formula that was useful for question 7, will be the equation. All right, then there's question 8 and 9. These are the derivative calculations. You will probably need a couple formula for differentiating multiplication product rule. For the product rule, we do multiplication. We try to find the derivative. Differentiate the first one, keep the second one, plus differentiate the second one, keep the first one. That's product rule. Another thing that you might want to remember is how to differentiate trig function. Let's see, derivative sign is cosine, and derivative cosine, you kind of remember trig function. Trig function is negative sine. These two is a pair of cofunction, my derivative and your derivative, so there's a little change to the sign. Then there's tangent and cotangent. Derivative of tangent is secant squared. Is secant square of x, and derivative of cotangent is negative cosecant square of x. So this tangent cotangent is a pair of cofunction, and that's why they have very similar format as far as derivative. And then there are the two tricks: sine, cosine, tangent, cotangent, secant, cosecant. Derivative secant function is secant times tangent of x. It's a multiplication of two numbers. And then derivative of cosecant, because it's a cofunction, the derivative is negative cosecant x times cotangent of x. So these are all derivative for the trig functions. And what you can see, the cosecant and cotangent will be necessary as you're trying to finish up this question. These are relatable formula to this question. Of course, we don't need all of them, but be useful to have them all corrected. Number 9 is try to find the derivative of the division. So you might want to have quotient rule. And also there's a logarithm. So you remember derivative logarithm is 1 over x. So then for this, you will need a quotient rule that if you have division, then the derivative of division is denominator should be squared. Still going to be a division. Numerator is numerator differentiated, the denominator minus the denominator differentiated from the numerator. So it does look slightly similar to the product rule, except in a quotient rule you have division. So the derivative of division is another division, but in the product rule, it's multiplication. So the derivative of multiplication is also a multiplication format. See, they're very similar. I'm keeping them in the same order. It's called FG, but then there's a minus sign there. There's no minus sign. Product rule. The reason there's a minus sign I explained before, because the G is in the denominator, so G has -1 power. G -1. So if you apply power rule, G -1 has a derivative of -1 G squared. But G to the -1 power, -1 to the front power, -1 minus 1 is -2. So that's kind of the reason why we have to square the denominator. We also have negative sign there. That's the negative power of G. That's quotient rule. And then one more thing is derivative of ln, which equal 1 over x. The ln of x is 1 over x. So the derivative of x squared plus 3 would be, you have to apply the chain rule. So derivative of this one by itself is going to be 1 over x squared plus 3. Because of chain rule, that was the 1 over is because of the logarithm. Then you have to multiply 2x because of chain. So if you have anything inside the ln, the process differentiation in all chain rule. But none of these are going to be part of the formula, part of the solution. They're just formula related to the solution. If you try to answer the solution, you have to apply quotient rule. In the middle of the quotient rule, you might have to apply like this differentiation. Useful. It's a formula related to question 9. And I think it should be useful for other situations too, but situation. All right, number 10, it says logarithm differentiation. So you might want to try to review what is log differentiation. That is, you first have to have logarithm function, and then you will differentiate. So the process will be making this equal to y equal to x7 to the x. And then we're going to do the log first. So you take logarithm of the left side and take a logarithm of the right side. So log of both sides of the equation, and then with logarithm property, the power move to the front. So this is actually equal to sub x times ln of x. But there's no more exponent. The reason that logarithm is useful is to convert exponential calculation into multiplication calculation. Multiplication calculation can be differentiated in this product rule, but exponential calculation is only easy when the base is e. If the base is a variable, then that is slightly more complicated. At least we don't have available formula for multiplication. That's why we do the logarithm differentiation. So first step is logarithm. Second step is differentiation. So we differentiate left side and right side. We'll have y prime divided by y, which equal to product rule. 7 times ln of x plus 7x times 1 over x, which is 7. That would be what it is. And then right back to the y. The y equal to this big thing. So then y prime is the derivative value. And this is the main steps for this question. And that's really the meaning of log differentiation is to log of the functions input and output, and then take the derivative. First take logarithm, then take the calculation of left side and right side. Question 10. Any questions? We might not need that many formula for later sections. This one you have to review the derivative of trig function. What is the derivative of sine inverse? Is 1 over root of 1 minus x squared. What is the derivative of cosine inverse? It's negative 1 over root of 1 minus x squared. So these are all kind of connected. I think sine inverse and cosine inverse are the two most popular ones. One other one is tangent inverse. The derivative tangent inverse of x is 1 over 1 plus x squared. These are all the inverse trig derivative. All the inverse trig have division because I think the sine, cosine, tangent, they were all defined by opposite over adjacent. They're all defined by division. That's why their derivative have division on that in there. The rest, this is a maximum. You will find the derivative and then find the critical point and then calculate the endpoint value and the critical value. And the rest of them, I don't think we need that many formula. But feel free to look through the solution to see if there's any requirements. I think the first one, especially the calculation derivative, actually involved one of them. Just and I hope that helps. You might have to try to write a few versions of the formula sheet. Because at first it may feel awkward and not having enough space, and then when you write a few more versions of it, you figure out a way to count them all into a single piece of paper. And then another thing is being able to use it, see if we're useful, and see if you actually know how to use it. Any questions? Right. I prefer, if we need any formula sheet, I prefer having students make their own formula sheet. Because that way you know what's useful for you. I mean, I had it before. I gave students a formula sheet, and then they don't know which formula is at where. And then even if they can find a formula, they don't know how to use it since the format is not like fitting for you. So So try to figure out which way to have the formula organized to make it meaningful. Some people organize based on the content, like chapter 1, these are the formula for chapter 1, chapter 2, these are formula for chapter 2, and then chapter 3. Some people prefer it that way. Some people prefer having the type of question, like for which type of question we would use which type of formula. So which way do you organize it depending on the way you think the easiest to use it. Any other question? All right, that should be it for today. I hope to see you on Thursday. Make sure that you don't oversleep. Having your formula ready, have your calculator ready. Thank you. I mean, the whole semester, I know many of you work really hard. Thank you. Do you need it? No. Yeah, they should still have it. Okay. Last time I said. I see you Thursday.